NEC Article 310.15b3 outlines the requirements for derating the ampacity of conductors when multiple current-carrying conductors are installed in raceways. The primary reason for this derating is the generation of heat by the conductors themselves, which can lead to elevated temperatures within the raceway and a subsequent reduction in the conductor's capacity to carry current safely. However, an exception to this rule is provided in NEC Article 310.15b3 specifically for conductors installed in raceways that are embedded in concrete. This exception is particularly relevant to Walkercell Infloor systems, given their design which incorporates embedding within concrete slabs. The rationale behind this exception stems from several key factors. Firstly, concrete provides thermal mass. Concrete is characterized by its high thermal mass, enabling it to effectively absorb and dissipate heat compared to air. This characteristic significantly mitigates temperature increases within the raceway. Secondly, conductors are spaced apart. In a typical Walkercell grid system, conductors are deliberately spaced apart, usually by a minimum distance of 2 inches. This spacing facilitates air circulation and promotes heat dissipation, preventing localized hotspots. Thirdly, raceways are closed. The raceways used in Walkercell systems are designed to be closed, which serves to prevent the accumulation of dust and other debris. Such accumulation can otherwise impede heat dissipation and exacerbate heat buildup within the raceway. Based on the exception detailed in NEC Article 310.15b3, it is generally not required to derate the conductor capacity for conductors installed in a Walkercell Infloor system. This determination is based on the collective benefits derived from the concrete's thermal mass, the spacing of the conductors, and the use of closed raceways, all of which contribute to minimizing heat buildup within the raceway. The NEC, or National Electrical Code, is a comprehensive set of standards and guidelines for safe electrical installations. Article 310 specifically addresses conductors for general wiring, outlining requirements for their insulation, ampacity, and installation methods. Ampacity, in this context, refers to the maximum amount of electrical current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The NEC provides ampacity tables, such as this found in 310.15, which specify the allowable ampacities for various types of conductors based on their size, insulation, and the ambient temperature in which they are installed. When multiple current-carrying conductors are bundled together in a raceway, conduit, or cable, the heat generated by each conductor can raise the overall temperature within the enclosure. This elevated temperature reduces the ability of the conductors to dissipate heat, effectively lowering their ampacity. To address this, the NEC requires that the ampacity of the conductors be derated, meaning it must be reduced to a value lower than what is listed in the ampacity tables. The derating factors are specified in 310.15b3 and are based on the number of current-carrying conductors in the enclosure. The exception provided in 310.15b3 for conductors embedded in concrete recognizes that concrete provides a significant heat sink. The thermal conductivity of concrete allows it to absorb and dissipate heat more effectively than air, which helps to keep the conductors cooler and maintain their ampacity. The specific requirements for this exception may vary depending on the edition of the NEC being used, so it is important to consult the latest version of the code for the most accurate information. In addition to the thermal properties of concrete, the spacing of conductors in a Walkercell system also contributes to their ability to dissipate heat. By maintaining a minimum spacing of 2 inches between conductors, air can circulate around them, allowing heat to be carried away more efficiently. This spacing helps to prevent localized hotspots from forming and further reduces the need for derating. Closed raceways used in Walkercell systems also play a role in maintaining the ampacity of the conductors. By preventing the accumulation of dust and debris, these raceways ensure that the conductors are able to dissipate heat effectively. Dust and debris can act as insulators, trapping heat and raising the temperature of the conductors. By keeping the raceways clean, the conductors are able to operate at the rated ampacity without the need for derating. It is important to note that while the NEC provides an exception for conductors embedded in concrete, it is still necessary to ensure that the installation meets all other applicable requirements of the code. This includes verifying that the conductors are properly sized for the load they will be carrying, that the overcurrent protection devices are appropriately rated, and that the installation is in compliance with all other relevant articles of the NEC. Furthermore, it is crucial to consult with a qualified electrical engineer or inspector to ensure that the specific installation meets all applicable requirements and is safe for its intended use. The NEC is a complex and ever-evolving document, and it is important to stay up to date on the latest changes and interpretations to ensure that electrical installations are performed in a safe and compliant manner. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Walkercell Infloor systems are a type of underfloor distribution system commonly used in commercial buildings to provide power, data, and communication services. These systems typically consist of a network of metal raceways or ducts embedded in the concrete floor slab. The raceways provide a pathway for electrical and data cables, allowing them to be easily routed and accessed throughout the building. Walkercell systems offer several advantages over traditional overhead distribution systems. Firstly, they provide greater flexibility in terms of layout and design. The location of power and data outlets can be easily changed or added without the need for extensive rewiring. Secondly, they improve aesthetics by concealing the cables and wiring beneath the floor. This creates a cleaner and more organized appearance. Thirdly, they reduce the risk of damage to cables and wiring. By protecting the cables within the raceways, they are less susceptible to physical damage from foot traffic or equipment. The installation of a Walkercell system typically involves embedding the raceways in the concrete floor slab during the construction of the building. The raceways are usually supported by a network of steel supports or hangers to ensure that they are properly aligned and positioned. Once the concrete has been poured and cured, the electrical and data cables can be pulled through the raceways. Access to the cables is provided by a series of access points or service fittings that are installed flush with the floor surface. These access points allow for easy connection and disconnection of equipment and devices. When designing and installing a Walkercell system, it is important to consider the specific requirements of the building and the types of equipment that will be connected to the system. Factors such as the power and data requirements, the layout of the building, and the type of floor covering will all influence the design and installation of the system. It is also important to ensure that the system is properly grounded and bonded to prevent electrical hazards. The grounding and bonding requirements for Walkercell systems are specified in Article 250 of the NEC. In addition to the NEC requirements, there may also be local codes and regulations that apply to the installation of Walkercell systems. It is important to consult with the local authorities to ensure that the installation is in compliance with all applicable codes and regulations. Proper planning, design, and installation are essential for ensuring the safe and reliable operation of a Walkercell system. By following the guidelines and requirements of the NEC and other applicable codes and regulations, it is possible to create a system that provides a flexible, aesthetically pleasing, and safe solution for distributing power, data, and communication services in commercial buildings. When considering conductor derating and Walkercell infloor systems, several factors should be taken into account. Firstly, the number of current carrying conductors in each raceway should be carefully evaluated. As the number of conductors increases, the amount of heat generated within the raceway also increases, which can lead to a reduction in ampacity. Secondly, the ambient temperature in the area where the Walkercell system is installed should be considered. Higher ambient temperatures can further reduce the ampacity of the conductors. Thirdly, the type of insulation used in the conductors should be taken into account. Some types of insulation are better able to withstand high temperatures than others. Fourthly, the size of the conductor should be selected based on the expected load and the derating factors that apply. It is important to ensure that the conductors are adequately sized to carry the load without exceeding their temperature rating. In addition to the NEC requirements for derating, it is also important to consider the recommendations of the Walkercell manufacturer. The manufacturer may have specific guidelines for derating conductors in their systems. These guidelines should be followed to ensure that the system operates safely and reliably. When in doubt, It is always best to err on the side of caution and derate the conductors to a greater extent than what is required by the NEC. This will provide an extra margin of safety and help to prevent overheating and potential electrical hazards. Proper conductor derating is essential for ensuring the safe and reliable operation of Walkercell infloor systems. By carefully considering the factors discussed above and following the guidelines of the NEC and the Walkercell manufacturer, it is possible to create a system that provides a safe and efficient means of distributing power, data, and communication services in commercial buildings. The NEC provides specific tables and calculations for determining the appropriate derating factors for conductors in various conditions. These tables and calculations take into account the number of current carrying conductors, the ambient temperature, and the type of insulation used on the conductors. It is important to consult these tables and calculations when derating conductors to ensure that the correct derating factors are applied. In addition to the NEC requirements, there may also be local codes and regulations that apply to conductor derating. It is important to consult with the local authorities to ensure that the installation is in compliance with all applicable codes and regulations. Proper conductor derating is not only important for safety, but it is also important for the long-term performance of the electrical system. Overheating of conductors can lead to insulation breakdown, which can cause short circuits and other electrical problems. By properly derating the conductors, it is possible to extend the life of the electrical system and reduce the risk of costly repairs. When selecting conductors for a Walkercell system, it is important to choose conductors that are specifically designed for use in underfloor applications. These conductors typically have a durable insulation that is resistant to moisture and abrasion. They may also be shielded to protect against electromagnetic interference. The use of appropriate conductors is essential for ensuring the long-term reliability of the Walkercell system. In addition to the conductors themselves, it is also important to select appropriate connectors and terminations. The connectors and terminations should be compatible with the conductors and should be designed for use in underfloor applications. They should also be properly installed to ensure a reliable electrical connection. The installation of a Walkercell system should be performed by a qualified electrical contractor who is familiar with the requirements of the NEC and other applicable codes and regulations. The contractor should have experience in installing underfloor distribution systems and should be able to ensure that the system is properly grounded, bonded, and derated. A properly installed and maintained Walkercell system can provide a safe, reliable, and flexible solution for distributing power, data, and communications services in commercial buildings. However, it is important to follow all applicable codes and regulations and to consult with qualified professionals to ensure that the system is installed and operated safely.